this video, we're going to focus on functions. And before we start the 2022 question, let's just have a little bit of revision about functions. Functions are where we have an input and output table. We can have an x and y axis, our x-axis and our y-axis. So if we input a value for x, we will get a value for y. We have linear equations, straight lines. We have quadratic equations, which can come in any part of the graph. This one has two roots, here and here. We also have cubic equations, which start high, end low, or start low, end high, depending on the type of cubic. This is one example. This is x cubed. The quadratic was x squared. The linear was x to the power of 1. We also have exponential growth, 2 to the power of x and 3 to the power of x as junior cert. They look like this in a graph. 2 to the power of x is this one, approximately. And 3 to the power of x climbs a bit steeper. And we have other functions. We have cos x at leave insert, which we have the graph. Cos x looks like this on a graph, the wavy shape. And sin x looks like this on a graph, a very similar look. So the 2022 question was, we were given part of the cos x graph. If we have a little bit of knowledge about cos and sine from trig, this is easy enough to do. The value of sine of 60 on a calculator you're asked to do, so you just type into your calculator sine 60 degrees is equal to, and we're going to put this on the graph then. The sine of 60 is root 3 over 2. It's one of the ones that you'll remember by the time you do the leave insert. And root 3 divided by 2 is equal to, correct to one decimal place, 0.866, to correct to 3 decimal places, to one decimal place. This will be 0.9. It's closer to 0.9, but this is obviously the most accurate version. And then we're asked to graph y is equal to sine x. This would have thrown a lot of people in 2022. They might not have practiced this. We are given two values. The sine of 0 is equal to 0. So the point 0, 0 is on the graph. The sine of 90 is equal to 1. So we go 90 degrees up to 1. And we have the sine of 60 degrees is 0.866 or 0.9. So if we go to the 60 degrees, we can go up to 0.88. So approximately here. And if we know where they are equal, we'd get the exact point, and you guys should know that the sine of 45 and the cos of 45 are both equal. So that's the point of intersection of these two graphs. So it's a curvy shape up and across. You could use your calculator for 15, 30 all the way across and get all these inputs into your calculator to get the output or the y value. So this is how the graph of sine x and cos x would look between 0 and 90 degrees and between 0 and 1 on the y-axis. And part C of this question, part C for the good guys that wouldn't panic, you're asked to use your graph to estimate the point of intersection. So we have an exact estimation. If we didn't have the exact estimation of 45, we would have got pretty close to it, and there was a range of values accepted here. But when x is equal to 45 degrees, y is equal to 1 divided by root 2, or root 2 over 2 in your calculator, which is 0.707. So that will be the answer for this one. Exactly, you would estimate from your graph and hopefully be pretty close to these numbers. So now we're asked to draw a sketch of each of the following functions. So it actually says draw each of the following functions in the domain. So we have 5 values for x: -2, -1, 0, 1 and 2. We're going to put these values into the function and get an output or a y value. You could use the input output table on your calculator. 10 by -2 -4 by -2 squared. I'm just going to write them all out first. 10 by -1 -4 by -1 squared. You should know this is going to be an n shape, with the negative x squared will give us an n shape like this. Then we have 10 by 0 -4 by 0. That's easy enough. It's going to be equal to 0. So the point 0, 0 is on this graph. Then we have 10 by 1 -4 by 1 squared. We should also see symmetry on this graph. 10 by 2 -4 by 2 squared. So you just use your calculator and then replace the -2 with -1 and 0 and 1 and 2. Write out all your answers. The answer is -20, -20, -4 by plus 4, 20 minus 16 is minus 36, minus 10 minus 4, minus 14, 10 minus 4 will be 6, and 20 minus 4 by 4, 20 minus 16 will be 4. So I would recommend jot them down as points. Minus 2 minus 36. You can see you've got 10 minutes. There's two parts to this. When x is minus 1, y is minus 14. You've double checked on your calculator all your results. 0, 0. When x is 1, y is 6. When x is 2, it's starting to come back down, y is 4. So putting these values on your graph, minus 2 minus 36 is approximately here. Minus 1 minus 14 is approximately here. We have 0, 0 already on. 1, 6 just above the line. 1, 6 and 2, 4 just below the line. So you can see it's coming up. It's coming up and then it's going back down. Let's do the last part of the line again. Just coming back down. That's a terrible attempt. Third attempt. Needs to curve back down. So this is 10 minus 4x squared, 10x minus 4x squared. And the next one, y is equal to 3 to the power of x, we introduced earlier, exponential function. So we have values for x, minus 2, minus 1, 0, 1, and 2. So just type these into your calculator. Get your y values. So just set up your calculator. 3 to the power of minus 2. If you don't want to use a calculator, this is 1 over 3 to the power of 2, or 1 over 9, which is 0.11111. So when x is minus 2, it's just above the line. It never touches the line. So 1 over 9, I'll just write in here for ease of use. 3 to the power of minus 1 is 1 over 3 to the power of 1. So 1 over 3, 0.333, nearly halfway up. It climbs very gradually. Then when anything to the power of 0 is equal to 1, so 3 to the power of x goes through 0, 1. 3 to the power of 1 is 3. So 2, 3. And 3 to the power of 2 is 9, 2, 9. So you can see exponential growth grows quite quickly and comes back down and never touches the x-axis. It will veer towards it, called an asymptote. So this is your graph of 3 to the power of x. In this function question, we have p and w. It doesn't have to be x and y. We also have a h in here. So we're going to input values for w and h. W 70, h 60, 0.65. And this is based on Frida starting an exercise program. She wants to increase her power output p. So her weight, the power output, is equal to 36 times her weight plus 62 times h plus 1800. So W is 70 and H is 0.65. I'll just put in 0.65 and then just type all of this into your calculator to get the power output. And I check my answer twice, 4360.3, 4360.3. And Frida's weight is kilograms, just to check, and height H is in meters. Now after 1 week, her power output has increased by 8 and her weight has not changed. So now we have an unknown variable. So h is the unknown variable. Work out the new value of h. Now Frida's weight and height, and it's the height that she can jump, not her height hasn't grown in a week. So let's have a look. Her new power output is 4368.3. Okay, so 4368.3 is equal to 36 times, just double check here, her weight has not changed, the W, 70, plus 62 by h, how much she can jump, we don't know what that is, so we're going to leave as h, plus 1800. So we can do this in one step. 4368.3. We're going to bring across 36 by 70. I'm just going to show you how you can type this into a calculator in one go. And we're going to bring across 1800 to make it negative. and that will all be equal to 62h. So instead of writing 62h, we can divide by 62 and type this into our calculator with the fraction button. This is giving me 0.779. 0.779, and we're asked to correct 2 decimal places, 0.78. So she can jump quite a bit more, an extra 13 centimeters. The next part of this question shows the graph of P for different heights when W is 70. The graph cuts the y-axis at 4320, which we can see here. So we're asked to draw a graph to show the values of P for different heights when W is equal to 80, using the same axis, scale and domain, and state where on the diagram the value of P where your graph cuts the y-axis. Okay, let's look back at the formula. 36W plus 62H plus 1800, and then we have a weight of 80. So the power output for someone with a weight of 80 is 36 times 80. The 62H we leave off to the right here, 62H, and we'll bring the 1800. So we can see 36 by 70 plus 1800 will give me the 4320. So we're just adding on an extra 10 by 36. So we're adding on 360 here. Just double checking on a calculator in a minute. 4680 is what this should give me, these two. So just checking, 4680 it is, plus 62, keep leaving out the 2, 62H. So it's going to cross at 4680, and it's going to be parallel. The H is going to go up, it's a straight line. And this we leave to here when W is equal to 80. That's all they're looking for here. The last part of this question is manipulation formula. Free to find the second formula for power output, and she sets the two formulas equal. Here they are. And we're asked to write H in terms of W and F. So we have 80H on the left. We want H equals, and they give a clue here, 62H. So we have 80H minus 62H. We'll isolate H on the left. That's going to be equal to the 36W. That's already there. I'll bring this 60W across, minus 60W plus 1800, and then plus 15F. I'll bring the 1300 across as well, plus 1300 and plus 15F. So 18H will be equal to minus 24W plus 15F and then plus 3100. And to get H on its own, we just divide this whole expression by 18, 24W plus 15F plus 3100. We could divide them all by 18 and put an 18 on the bottom like this, or one big line across with an 18 on the bottom. Either one will do. Save it our pen, just write 118. So that's the end of this question. In this question, a sheet is folded in half a number of times. H of x is equal to 2 to the power of x is the number of layers after x folds. So 2 to the power of 1 is equal to 2. 2 to the power of 2 is equal to 4. 2 to the power of 3 is equal to 8. That's all we're doing here. We've got our exponential 2 to the power of x, 16, double 32, double 64. We're asked to list the elements of the domain and the range. So it's your knowledge of domain and range. Now D comes before R in the alphabet, and X comes before Y. So domain is X. So X are my 1, 2, 3, 4, 5, 6. And the range are the answers that these give 2, 4, 8, 16, 32, and 64. Part C, work out the least number of folds that would be needed to have more than 500 layers. So this is an inequality, more than, greater than 500. When will 2 to the power of x be greater than 500? Well, we can do, we've got 2 to the power of 6 is equal to 64, so I think trial and error is probably the best way here, rather than using log rules, which you will do at leave insert. 2 to the power of 7, 128. The one I get you to remember, 2 to the power of 10 is equal to 1024, easy to remember. 2 to the power of 9 is 512, so that's going to be our answer here, 9 folds. We could keep on building up from 2 to the power of 7, 2 to the power of 8, 256, and then obviously 2 to the power of 9 is 512. So a little bit of trial and error, get you there quite quickly here. 9 folds. The next part is scientific notation. So 12 folds, we said 2 to the power of 10 was 1024. 2 to the power of 11 is equal to 2048. And 2 to the power of 12, just type it into your calculator, 4096. So that you can bring in scientific notation here. How do you write 4096 between 1 and 10? Let's put the decimal here. And we've moved it how many places? We've moved it 3, so that's where the 10 to the power of 3 comes in. You're multiplying by 1000, which would get the decimal back to after the 6. And explain what the following statement means in terms of folds and layer. Well, after 14 folds is greater than 10,000. Is it? Let's have a look at 2 to the power of 13. Going to be 8,192, 8192, and then 2 to the power of 14 is going to be 16,000, and that's going to be just less than 400. 384. Just check it on a calculator, and then put a tick in the correct box to show what kind of pattern it is. Well, we introduced linear at the beginning, straight line, quadratic, U-shape, N-shape, exponential growth, 2 to the power of x, 3 to the power of x. So it's exponential growth for this one. And we call that the doubling pattern too. It's doubling each time, or that we have a power. The unknown is the power, which would be another way to show that it's exponential. So it gets a little bit tricky here. After a certain number of folds, there are k layers. They're really testing the higher end students with this one. How many layers will there be after 3 more folds? And give your answer in terms of k. Okay, well, 2 to the power of x, we don't know what x is equal to k. Let's just assume this is 2 to the power of 3 is equal to k. And we know k is 8 here. The next answer would be 16, 2 times k. 2 to the power of 4 would be 2 times k. 2 to the power of 5 would be 4 times k, 2 by 2. And 2 to the power of 6 will be 8 times k. Let's just check this. 2 by 2 by 2 is 8. 2 to the power of 6 is 64. And 2 to the power of 3 is 8. And you can see that 8 times 8 is 64. So it's 2 to the power of 3. So it's going to be 8. So 2 times 2 to the power of x, whatever x is, plus 3 will be 8 times the original number. Because of the exponential growth, it's doubling, 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 which is multiplying it by a factor of 8. After a certain number of folds, there are 2 to the power of p layers. How many will there be after 3 more folds? Well, that's going to be 2 to the power of p plus 3. We kind of introduced this one here. 3 more will be p plus 3. So with your brilliant knowledge, you've kind of answered this one above. 2 to the power of p plus 3 goes from 2 to the power of 3 to 2 to the power of 6. We use a real life example, which is always handy in these ones where we have unknowns. So a good bit of knowledge required in this one. Exponential growth, functions in the scientific notation. And the last functions question in this video. Solve the following equation. It's a quadratic function, 2 decimal places, quadratic formula, minus b plus or minus the square root of b squared minus 4ac. You really want to see this question on your exam because it's just calculator use. All divided by 2a. Go to the formula booklet if you don't remember it. A is the number in front of x squared. Take your time and write it out. B is the middle term, minus 4. And C is the final term, minus 7. So minus 4, I would prefer you to write as just 4, plus or minus, but we're going to just use plus and then change the calculator to minus. The square root of, I prefer to put in just 4 squared. If you put in minus 4 squared like this, it will give the calculator reads it as minus 16, so be careful. Don't do this. And then minus 4 by a, which is not needed if it's 1, by c, which is minus 7, all divided by 2 times 1. You can probably simplify this a bit in your head. We're going to have 4 plus or minus the square root of 4 squared, 16, and then the minus with the 4 and the minus with the 7 give us a plus 28. 16 and 28 is 44, all divided by 2. So you have 4 plus the square root of 44 divided by 2. And 4 minus the square root of 44 divided by 2. And these two answers give, I'm getting 5.316 for the positive one. Minus 1.316, just double checking that, 316 for the negative one. And what are we getting? 2 decimal places here. 5.32, or and minus 1.32. So get good at functions. I'll make another video soon on functions too.